Welcome to the Beneski Museum of Natural History at Amherst College. We're about to take a tour with Dr. Stan Rachootin of Mount Holyoke College. Stan began working at Mount Holyoke in 1984 and over decades has taught numerous classes on Darwin's work. Today he's going to take us on a tour of some of the key elements of the Beneski collection.
So this is Megaloceros hibernicus, generally called the Irish elk, and this specimen does come from Ireland, but actually the term Irish elk is very much like what Mark Twain said of the Holy Roman Empire. It was neither holy nor Roman nor an empire, but Irish elk was found all over the place across Europe, and then there were relatives of the Irish elk that went all the way across Asia, and there were other species of the same genus, again, still very, very big deer, but instead of having these big palmate antlers, their antlers would go out straight and very thin, and then have a whole bunch of tines at the end of them, sort of like fingers. But again, huge, huge antlers. So, is this a male deer or a female deer, or you can't tell? What do you think? Male? Okay, why do you say it's a male? Okay, do female deer have antlers? Do any female deer have antlers? Hint. Yes, which one? Do you want a hint? Da 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 da. Very good! Which are also called caribou. Okay, what else is weird about caribou or reindeer other than the fact that we have songs about them? How do they get around in the world? They walk, yes. No, they get around in big herds. And in general, and no other deer does the big herd thing. They will go around in little family groups, but not gigantic herds. The other thing which is unusual is that the females have antlers, and the females keep their antlers on all through the winter when they are, in general, all pregnant also. The males make antlers, they go through the rutting season, and then the males drop their antlers, and then they go back in the herd, but they don't have antlers, and they're thus at the bottom of the pecking order, or whatever reindeer do to each other, probably not pecking, and they get the worst places to feed, and they don't have these big antlers, which can also be used for removing snow and pushing the snow off the lichens that they are eating. So they get less food, they have less opportunity to get rid of the snow. They're just, not doing as well, whereas the females are getting what browse there is, and which they need because they're pregnant. And then the females drop their antlers at the same time they give birth. And because there are a lot of antlers scattered around at that place, they can chew on the antlers and get some of the calcium and some of the phosphorus back, because otherwise antlers are dead bone, and there's no way to resorb it from the top of your head. But you can at least chew on it and get something back in an environment where there's almost no calcium and there's almost no phosphorus. Okay? So it all makes sense. Yes? Well, the herd, when it really matters, when the females are pregnant, is much more matriarchal. And I don't know what's going on in the rest of the season when nobody has antlers, or the antlers are just growing. But then there's plenty of food; it's less of a big issue. Okay, so if you look at those antlers in this deer, this is a very impressive specimen, by the way. As far as I know, on the East Coast, the one with the most impressive antlers is at Yale, and the one with the smallest antlers is at Harvard. So there. Okay, but this one is pretty close to the Yale one. These antlers can weigh as much as the rest of the skeleton. And so if you think about what we talked about allometry, that allometry is a line segment, it is not a line. You can't just keep extending that line until you get to a deer that has antlers that weigh, say, 4 times as much as the skeleton, which you would get to very quickly with how sharp that line is. Meanwhile, the smallest deer around today will have antlers about this big, and the whole deer is about that big. Bigger than a chevrotain, which are not deer, but not much bigger than a chevrotain. So this is a place where we get positive allometry. As the body gets bigger, the antlers get even bigger, but you can't extrapolate on that line because you get to a place very quickly where you are beyond a place where any deer could get up and walk. And this is very much along the same lines as when we were talking about allometry in class. You can't figure out the heartbeat, which gets faster and faster as you get smaller and smaller, say in utero, and figure out at the time of a zygote is the heartbeat. The heartbeat of a single fertilized egg is not going at 10,000 beats a minute or something like that, because for one thing, there's no heart. So you can't extend allometric lines or allometric line segments beyond the data you have. But these are on a very nice allometric line with the antlers of other deer. You can see that there are really big impressions of blood vessels because these are pumped out really, really fast. Like 6 or 8 weeks probably. And they are really, if you ever touch a deer that has velvet that is making its antlers, it will be hot. It is physiologically very, very active. This is the fastest growing mammalian tissue, which is not a tumor. And so if you want to study something like angiogenesis and how it can be kept under control, this is a really good model system, is how antlers grow without turning into, say, cancers. Because a lot of what they're doing is very much like what you would be running into in a cancer, except these aren't cancers. What do you think the deer is doing with the antlers? Now clearly this is a huge investment to put your body, your skeleton weight into bone on your head. So what are they doing with it? Yes?
Does it show fitness to a female?
Okay, to exhibit how worthy they are to a female. Now this might be something sort of along the lines of the peacock. Well, look at the incredibly idiotic thing I have coming out of my rear end, and there are tigers here, and yet I'm still alive. And so it could be something along those lines in terms of show. But what else could they be doing with it? But what else could they be doing with it? Yes? Sorry? To shoveling snow away? Okay, now in caribou, you will notice that they are often asymmetrical. The one that we have on loan from the Amherst Natural History Museum, actually, up in lab, has on one side a big sort of plate-like piece, which is used for snow removal. But do those look like, how would you use those for snow removal? For snow shoveling? Not very good. What else could you do with antlers? Fight. Okay, so if you were going to fight with these and charge into another Irish elk, you would want the tines going where? Forward. Okay, now for those tines to be going forward, where does your head have to be? Your head has to be basically between your wrists here. Now, if you stick your head between your wrists and have your antlers going out for 3 feet on each side, how exactly do you charge? Or do you just stand there and wiggle? Is this going to work as a way of fighting? Okay, so for a long time, that was the conclusion that people had, which was this was for show. One male looks over at another male. Now, exactly how the deer knows, the buck would know how big are my antlers. Now, we did have one thing that could give them a hint, because remember that the antlers have a mental impression, and that when the pacemaker was put on one developing antler when it was in the velvet stage, it curled, but the other antler, which didn't have the pacemaker, also curled forward, and the next year both antlers remembered we had curled forward, and so they did it again with no pacemaker. So there is a mental impression of your antlers. Or maybe they're staring into a pond and then they fall in like this one did, and that's why it has this nice tea color, falling into a bog and then being preserved in an Irish bog. And they're just trying to get a reflection. How big are my antlers? Because I really want to be able to judge whether I should get into a whatever with that other male over there. Or because these are big animals and they have these big frou-frous on their head, that is really those are two of the warning signs of K selection. And that means that if they wait around next year and they're still alive and they're getting a little older and more mature, they're going to get bigger antlers, so maybe I should just wait a year or two. That would probably also work, and that's what you do in K selection. You wait for the right moment. See, R and K, it still works. Okay, so that's another possibility. And that this would be a way of keeping them from fighting. And that was the general view of this until someone that we actually talked about in class, Valerius Geik, he spent many years, and he was the one who came up with the idea of maintenance and dispersal phenotypes, Valerius Geist. And his experience largely came from living with lots and lots of mountain sheep. And he would just live with the mountain sheep and observe them. And the mountain sheep have really, really big horns, but under them they have a whole lot of sort of styrofoamy bone, sort of foamy, that they can smash their heads into each other without giving themselves concussions. So it looks like they're not going to really necessarily hurt themselves very much. But what Geist saw when he watched these mountain sheep smashing their heads into each other is that pretty often one of them was pushed off the cliff and fell 5,000 feet to its death. And that suggests that got him thinking that if you're going to have something which can work as sort of a ritualized display, you always have to back it up with something that could actually cause somebody to die. That's what keeps the currency valuable. And otherwise, it's going to be sort of like, tulips in the Netherlands in the 17th century when everybody decided, we're going to put all of our money into tulips. Oh, that's an even better tulip bulb to have. We're going to put even, 3 houses worth of krona into that tulip bulb. And then they decided, tulip bulbs are poisonous. We can't even eat them. And, they're not really worth the thousands and thousands of guilders that we're putting into tulip bulbs, and the whole thing crashed. You need something to keep the currency going, like, for instance, killing the one who shouldn't have been in the fight. So how could something like this kill another Irish elk? I suspect if you smash your head down on the backbone of another one and you catch it with the flat part of the antler, that would probably do serious harm. So there probably is a way that this could have been used to keep the currency up. And then in general, if you suspect your antlers aren't as big as his antlers, you don't get into a fight. And then you wait a year or two. Okay? Otherwise, notice that the neural spines going down the back of the Irish elk are really, really long because you have this tremendously heavy structure that you are carrying around, and you need a place to attach those muscles to suspend them onto the anterior part of the back. And all your other favorite features from the Artiodactyl lab are here: double polea astragalus, running around on 2 toes. This is a standard deer. It's just a gigantic deer and probably about as big as the antlers could get on a deer. Okay? And as I said, they did go extinct, and one thought actually about this is that going from a more tundra type environment to an environment which, as things warmed up, turned back into forest, this doesn't work as well in a forest. you're going, it's hard to run through the forest with antlers, at least while you have antlers like that, which of course are only on the males. Okay, any questions? Let's keep going.